Now today's topic is pulley. At first all of you see this diagram. This is a grooved ream and this is a disc over which a rope is being whirled here over this grooved ream. Now we'll read first what is a single fixed pulley or the applications of single fixed pulley. A single fixed pulley can be used in two ways: as a fixed pulley by keeping the axis of rotation fixed, unchanged; as movable pulley by changing the axis of rotation by keeping the whole frame movable. That is, this is your movable pulley. This is the single fixed pulley and single movable pulley. What is this movable pulley or fixed pulley? Here the axis of rotation is fixed, here the axis of rotation is not fixed. Now what is a single fixed pulley? A pulley which has its axis of rotation unchanged is called single fixed pulley. And single movable pulley is what? A pulley whose axis of rotation is movable, not fixed position, is called single movable pulley. That means what? This is a diagram of a movable pulley. This is a diagram of a movable pulley. This is the effort and this is the tension. Both are in the same direction. And here it is the load. Load is being suspended here. This is your single movable pulley. Now, see what is the relationship between mechanical advantage, velocity ratio and efficiency of a single fixed pulley. Now mechanical advantage is equal to 1. Why? Because in case of single fixed pulley, load is equal to effort, and we know mechanical advantage is equal to load by effort. As a result, it is 1. Why? Both equals to T by T. They will get cancelled and it will be 1. Now velocity ratio, VR. Velocity ratio is what? dE by dL. Here both are at the same distance, that is expression will be d. Velocity ratio is also 1. Then efficiency is what? Efficiency is 100%. In actual practice, there is always some friction at the axle or in pulley bearings, so that the effort needed is little more than the load to be lifted. Thus, mechanical advantage is less than 1. Velocity ratio is 1, so efficiency is always less than 100%. Now, a question arises here: why there is no gain in either mechanical advantage or speed? Why is then fixed pulley used? A fixed pulley is used only to change the direction of effort to be applied. That is, with its use, the effort can be applied in a more convenient direction. Now, for a movable pulley, this is the expression for single fixed pulley. For single movable pulley, single movable pulley. Now, here in this case, I have shown you this diagram. You see this load will balance this 2T. That is L is equal to T plus T. This is your 2T. And effort is equal to T. Then mechanical advantage, load by effort, 2T by T, it is your 2. Now, when free end of a string is pulled up, the effort through the distance D, load is raised up to a by distance D by 2. Load is raised to a distance of D by 2. The reason is that the segment of the string on the both sides of the pulley moves up D by 2, that is D, if D equals to D, DL is equal to D by 2. Then only this expression will be there. And what is the velocity ratio? Velocity ratio is equal to dE by dL. When we will put this one, D by 2. This 2 will be here. This is your 2. Velocity ratio is also 2. Now, efficiency is what? 2 by 2. Efficiency is what? MA by VR, 2 by 2. This is your 100%. For an actual single movable pulley, due to friction in the pulley bearings or at the axle, weight of the pulley and the string effort is lifted up, a load L will be more than L by 2. So mechanical advantage will be always less than 2. Since velocity ratio remains 2, hence efficiency is less than 100%. Now, the mechanical advantage and the velocity ratio of the arrangement shown in the diagram, if suppose this is one pulley and one is your fixed pulley. This is your fixed pulley, and through this string here another pulley is being suspended and it is being fixed at some point. So this one, here is the load, here is the load is L, this is the effort, this is your tension, this is the tension, here it is the tension, and this is the tension. The mechanical advantage and the velocity ratio of the arrangement shown in the above diagram remains the same for a single movable pulley. That is ideal case, mechanical advantage is equals to 2, velocity ratio is equals to 2. Now, if suppose more than say 1 pulley, 2 pulley, 3 pulley, say if suppose there is an arrangement, a rigid support is there, at that time mechanical advantage is equal to 2 to the power n. N means what? N implies the number of movable pulleys. Now at that case, velocity ratio at one end each of a string passing over the movable pulley is fixed. So other end of the string moves up at twice the distance by the axle of the movable pulley. If the load is L attached to the pulley A, it moves up a distance x, then dl equals to x. The string is connected to the axle of pulley B, moves up a distance 2x. The string connected to axle pulley C moves up a distance 2 into 2x. Like this, the expression will be 2 to the power n. That is, if suppose there are 3 pulleys, then it will be 2 to the power 3. If suppose it is n pulley, then it will be 2 to the power n. Efficiency is always 100%. In actual practice, the weight of the pulley and the string and the friction between bearing and the pulley is reduced the mechanical advantage. So the efficiency becomes less than 100%. If mechanical advantage is less, then only the efficiency will get decreased. Now using several pulleys in 2 blocks and tackle. So what is a block and tackle? The number of pulleys are used in moving lower block is either equal or 1 less than the number of pulleys in the upper block. This is called block and tackle system. When they are get attached with the help of a string, this is called a tackle system. Now see, the pulley system is only a force multiplier, and just like other machine, there is no gain in energy. This can be seen as follows. The work done by the effort is equal to what? Effort into effort distance. What is an effort distance? I am showing you here. Effort distance. What is an effort distance? Say work done by the effort. This means effort into effort distance. This is the distance ND. Then it will be NED. Now work done by the load. This is your load into distance moved by the load. That distance is D. Then from here what we will write? Say from this expression we can write here that mechanical advantage is equal to load by effort, and this is equal to N. Then L is equal to NE. What will write? L is equal to NE. That means what? In this case, here what will write? NE into D. That means there is no gain in energy. There is no gain in energy. Why? This is work done by the effort. Work done by effort. This is work done by load. You getting? Now both the expressions are same. That's why there is no gain in energy. Now effect of weight of a pulley on a mechanical advantage, velocity ratio, and this one. So if suppose E is equal to T and L plus W equals to NT, then L is equal to what? NT minus W. And what we are going to write here? So we'll write NE minus W. Then mechanical advantage MA is equal to L by E. In place of L, we will write NE minus W by E, N minus W by E. This is an expression. Thus, mechanical advantage is less than ideal value N. Velocity ratio does not change, it remains N. And efficiency is what? Efficiency is N minus W by E by N, 1 minus W by NE. This is the efficiency. Now, for a greater efficiency, pulleys in the lower blocks should be as light as possible, and the friction in the wearing of the pulley should be minimized by the use of lubricant. Then only we will have a greater efficiency. The efficiency is reduced due to weight of the lower block of the pulleys. More the weight of the lower block, less the efficiency. Now, in case of what I told you right now, that in block and tackle system, there are two halves, two portions. One is called upper block and the lower one is called the lower block. What it is mentioned? If suppose efficiency is reduced due to weight of the lower block of the pulleys, if suppose here in the lower block the number of pulleys are more, weight is more, as a result its efficiency will decrease. If suppose in the lower block the number of pulleys is less than the upper block, then it will have a greater efficiency. Now, one more thing I would like to explain here, that say again I am repeating the same thing, that is your block and tackle system. Say, what is a block and tackle system? In this system of pulleys, two blocks of the pulleys are used. One block is upper, having several pulleys, is attached to a rigid support, and the other block is a lower, having several pulleys movable. This arrangement is called block and tackle system. Now, whatever the examples are given in the exercise, those examples are to be read nicely, and numericals you have to practice. And some reasoning questions are there in the chapter, that is question number 18. That questions are to be read nicely up to this much.